Hello, friends. Today, let me talk about the mathematics behind AI models or NLP models. We have learned linear algebra, calculus, probability in our pre university days or in our engineering colleges. But we don't know the practicality in the world. Mainly today, the AI is ruling the world. We have to know where these concepts are used during training or in the inference purpose. Let me start with the first topic, that is linear algebra. In linear algebra, let me tell you about the matrix. There are many mathematical operations we do in matrix. Maybe it's addition or multiplication or inversion. There are other types of matrix. Maybe it is a square matrix or identity matrix or transpose matrix. These are all we learnt during our educational period. This matrix multiplication we use in BERT or GPT. Why we use? We use it to convert whatever the word vector that we have for each sentence into query or key or value vector. Let me show that formula. This is what we do using matrix multiplication. Here we have used weight. Weight initially have random numbers. With each training, this is going to form a specialized knowledge matrix. This is what we called a parameter in the models. Then let me discuss about this word vector. What is this word vector? This word vector, what is vector? Vector means it has both a direction as well as magnitude in the vector space. So what is the use of it? So that we can compare between the two words, whether they are similar, whether they are meaningfully similar or meaningfully different, or whether they are present in the opposite direction, whether they have the same magnitude. Like that we can compare easily. And then we have another concept, that is feed forward network. This is what we use after the self-attention layer in BERT or GPT models. What is BERT? BERT is bidirectional encoder representations of transformers. It only does encoding. In GPT, that is the decoder only model, that is generative pre-trained transformer. In that we do linear transformation by making use of both weights and biases. Both these are matrix. We do matrix multiplication with the context vector what we get from the self-attention layer. Here in the feed forward network we do self-reflection. Means the word deeply know about its properties or features. In self-attention layer, basically we know about the relationship with other words. That is the context. Let me show the formula. Feed forward network is maximum of x w1 plus b1 w2 plus b2. In feed forward network, we goes through two layers. One is contracting layer, another one is expansion layer. Between this, we use activation. Activation maybe it may be sigmoid activation or ReLU activation. There, we make use of exponential or logarithmic formulas. This is the formula for feed forward network for self-reflection. That is x into w1 plus b1. In this second layer, w2 plus b2 with the output from the contracting layer. And then let me discuss about the logit. We calculate logit. If logit goes through another layer, that is softmax layer, we are going to predict the next word in GPT. This logit has many vector values so that we can predict the next word. This logit vector is going to be generated making use of matrix multiplication. It is the same formula as feed forward network, that is input a vector into the vocabulary matrix, that is it contains a volume of words what it has learned. And then we have biases like this. This is the vocabulary matrix, this is context vector, this is bias. Finally we get logit vector so that we can predict the words using softmax function. And then let me move on to the dot product, where we use dot product. Dot product we mainly use in both BERT as well as GPT. How? After calculating those QKV, we have to know the relationship between the words in deep. So we make use of dot product of query with the key value of all the words. And then we calculate attention score with that, and then we calculate attention weight making use of value vector of each word. And then we get finally context vector. Let me give the formula for that. That is q dot kt and then q dot kt divided by dk dot v. Here we apply soft max attention score, and then this is attention weight. These are the two formulas we use to generate context vector, as well as the probability of each word dependent on other words in the sentence by making use of this softmax function in attention weight calculation. We have another concept in dot product, that is cosinesimilarity. This is specifically we use in sentence transformers to compare between the two sentences, whether they are similar, whether they are dissimilar. or they are completely opposite to each other, so that we can make a classification between the two sentences. Let me give the formula for it. In this, we have a dot b, as well as in denominator we have the norms, that is a root of whatever the square of the vectors with summing all those squares. That in dot product, what we do, we multiply each vector value of both those vectors, and then we had those multiplication values to get the dot product.